Hi, everyone. Welcome to the Python for Beginners workshop hosted by the Columbia Global Centers and CYT Research Computing Services. My name is George Garrett. I'm Manager of Research Computing Services at CYT. So we're happy to bring you this program this fall as part of a university initiative to support international students and students who are living outside of the US. Global Centers has made it possible for students in 65 cities around the world to access high-end study spaces, to convene, connect, and be supported as part of the Columbia community. In addition to these spaces, Columbia Global Centers is developing programs and events such as this week's series of computer workshops. We previously held last week Intro to Linux and Intro to Scripting, Python for Beginners as well. Today will be Python for Beginners, and on Thursday, Intro to High Performance Computing. And I believe tomorrow we're going to be doing, maybe Wednesday, 3D modeling. So we're very excited to bring this programming to you. So again, we're part of Research Computing Services. If you have any questions or want to consider learn more about some of these things we're doing, we invite you to email us at rcs@columbia.edu. We also work very closely with the Foundations for Research Computing initiative, and they also have things like a Python user group. So with that said, I'll introduce the team of instructors and helpers we have today. Michael Weisner will be instructing, and Cesar Arias will be helping out with any of your questions. So as we go, if you have any questions, please drop them into the Q&A or the chat, and we'll be happy to assist you. So without any further ado, I'll hand it off to Michael.
Great, thanks, George. Hi, everyone. As George said, my name is Michael Weisner. I'm with the Research Community Services team, and we are going to be covering a introduction to Python. Just for a little background, I am primarily actually an R programmer, but I've used Python fairly extensively, and we'll be covering, sort of general usage of Python, the basics of how to use it. I'm going to introduce you to a handy tool called Google Colab, which is basically it's basically what's known as a Python notebook, but it's Google's version. And the reason I'm going to show it to you is because it's probably the easiest way just to get up and running Python code for most people. I'm going to share my screen so y'all can see. And if you have questions, it's going. I ask if you can. Hold on, just gotta get this situated a little bit. It'll be a little hard for me to see the Q&A and the chat, but if you want to ask questions in either one, my colleague Cesar will try to either answer in chat or stop me to ask the question out loud. And I'll encourage you to follow along. If you'd like to do this, you can either just watch or do it yourself. In chat, I'll just post a link. You can go here just to get started with Google Colab if you have a Google account. And once you're there, you could go to File and New Notebook just to start your own Python notebook. I've named this one Intro to Python. And I'm just getting set up. So just so everyone can see, Python is a programming language, and you can use it in something such as hold on, I did not mean to share this one. Too many things open. Did not mean to jump windows. Sorry. So you can use Python just if you have a Mac like me, or most computers have Python built in, and I can show you just really quick. So if I say Python 3 version, so my computer has Python 3.73 installed, so I could use Python here if I wanted to by simply calling Python. Actually, I don't know if this will work. think I'd have to put it in the thing, but you can call Python from your computer is just all I want to show. But a really popular way to use Python, especially if you were interested in doing scientific research or statistics, is these Python notebooks. And the reason why they're popular is that rather than running everything from like a command line or a terminal, you have these cells of code. So you'll see here, this is a little code snippet. We can type stuff in here. And then when we are done, what I was just trying to do, I'll show you. I can say print hello. I can run this little thing. And when I click or ran it, it printed hello to the screen. So this is kind of like the basis of how these Python notebooks work. You have these little sections. I'll show you. I can create some more code sections, and you see they keep popping up. And in each one, you can write code and execute it within that cell, and then right below it, it prints out the results of that cell. So it's popular because it's a really nice way to organize that in a really human readable way, and a way that makes your research really reproducible. I'm also going to say you have text here, which uses what's called markdown formatting. So there's some tricks to this, and it's a little beyond the scope of this, but just to show you, like I can do things like headers. So I could put a little hashtag here and say math, and I will. When I go down, you see it's much larger. Just to show you, if I wrote something below that, like this section will cover math, and then jump out of it. You can see that you can format it to make it almost like a report or like a PDF that has these little code chunks inside it. So I mean, the reason I named this math is because obviously one of the first things that Python is used for is doing mathematical operations. So I could do something like 2 + 2 = 3. I'm just hitting Control Enter to run that. I'll add some. I guess I have to add these manually. In a normal Jupyter notebook, it usually creates a cell for you after you run it, but I guess Google Colab is a little different. But yeah, so I can do 14 - 10 or 10 × 10. We get 100, and so we have fairly intuitive mathematical operations. I guess something interesting, it's that when division, it automatically, even though it's a whole number, it's a little different, and we'll get into what Python means when it gives us decimal points. You can also do, if I wanted to see like how like remainders, so 21 divided by 4, like how what is left over. So because 20 is divisible by 4, we're left with a remainder of 1. I've never actually used that, but it's just kind of nice. You can explore more. There's a lot that Python can do. This is maybe a little in the weeds, but so just something of note, when you're using Python, it uses what's called a read, evaluate, print loop, where you have input that it reads, Python evaluates it, then prints it, like here, and that's how it operates with these kind of cells. So you have this it's called a REPL or REPL, which is sometimes referred to, just so you ever see that. So that's math in a nutshell. Looks like, I just want to check. It looks like we have a couple. Yeah, chats. Is everyone doing okay? Caesar, are there any questions?
No, everybody's fine. Just one question about the website, how to get the Colab, but cool. Everybody's good right now.
Great. Okay, let's make a new section. We'll call this types. I'll add new code. So Python is what's called an object-oriented programming language, and it treats pieces of data differently. It classifies them in certain ways, and so that's why types is kind of important to know, because you should know what kind of data you're working with. So if I'll use this, I'll say type, and you'll see here I put this little parentheses here. That's because type is a function, which we'll get into a little bit later. But basically, a function is just a it's like a prepackaged snippet of code that executes some sort of predetermined operation. So in this case, type is going to tell us what type the input we give it is. So if I put 1 in here as the input and I run this, it tells me int. So what that means is that if I run type on the number 1, it's telling me that 1 is an integer. And similarly, if I say type of 2.0, as we had up above, and run that, it says it's a float. That's because it's a floating number. For those who may not be familiar, an integer is a whole number. Floating numbers have trailing decimal points. It can matter for things like rounding. Similarly, I could say type of a sentence or any sort of string of characters. I'll say hello there. And I see I put that into parentheses. And when I evaluate that, it says it's a string. That's how it refers to character data. Another one that's helpful is what's called a Boolean. So I'm going to say true here, as I capitalized it. True and false are Boolean, which means, it's a binary true or false, like a 0 or 1. It can be very helpful when you're evaluating things like if X is true, do Y thing. But that's what's referred to as a Boolean. It comes up here as bool. And then the other one that's kind of, I think, important to know starting out is what's called a list. So I'm going to say type here. And inside that, I'm going to put square brackets. And the square brackets, I'm going to put 1, 2, 3. And I will run that. And that's a special type of data structure called a list, which is one of the foundational ways of organizing data, or like a collection of data. It's kind of the basis of a lot of tools that Python uses. Similarly, anything could be in a list. I could, just to show, we could have a list of A, B, C. That's still a list. And you can also mix it up. Python doesn't mind if things are like A 2.0 3. It doesn't care. It still refers to it as a list.
Hey, Michael.
Yeah.
There's a question which Caesar answered kind of, but someone said, what is a float? I don't remember R has this type. Does R have floats?
Yeah. Float. R has integers and floats as well. Basically, let me see. Does R actually refer to it differently? R might refer to them differently, but R still differentiates between whole numbers as integers and floating point numbers, so floats is a fairly common way of describing it. But the real difference is that an integer doesn't have any decimal values, and floats do. So 2.5 is a float, whereas 2 or 3 is an integer. It can matter if you're rounding or evaluating. Sometimes it matters because sometimes with computers, if you use floating numbers, it won't actually properly evaluate. It'll round incorrectly. I think we can actually test something here. And I think, sorry, I have to, this was getting a little far. So I'm going to evaluate, and I say two equal signs, which is evaluating if something is true. So I asked, is 2 equal to 2.0? And it says true. But I also think sometimes it can get really weird, or if you get close enough to 2, it'll say it's still true. Yeah. So this is close enough to 2 that it's still saying it's true, which we know is not actually true. So sometimes it can matter, using integers and floats for certain reasons. I've also seen weird things, but I may be confusing with R, but I've seen weird things where something should come out to be, or there was some sort of process that should spit out an integer, but since it was actually a floating number, it rounded weird, and I got something like 1.99999. it can be a little confusing when you're trying to do matching stuff. So it's an important thing to be aware of, although it might not come up as like a big issue frequently. Okay, we're gonna start a new section. We'll call this variables. So, I mean, many of you may be familiar with variables from math class or statistics, and it might not be a surprise that in Python you can set variables. So, for instance, I can say x equals 5, and in this case, I'm using the equal sign to assign the value of 5 to x. If you are familiar, it sounds like we have some people who might know R. R uses a different symbol. That would, in R, it would be, actually, I'll show you another thing quick. I'm going to make a comment called R syntax. Python will ignore this comment when you start with in a code snippet. If you start with a hashtag, Python will just skip over this, which is helpful for marking your code. But so R would be something like this, where you have this little assignment arrow. So that's just something to note, that the assignment arrow wouldn't work in Python. So it's slightly different. But if I run this, you notice nothing happens. It doesn't print anything out. That's because I'm not actually asking Python for anything. We're telling it to assign this value, but we're not asking for what that value is. So if I want that, I'll just do it for clarity in another one. If I just type X, or actually print X, let's try that. And I run that, you see it prints 5, because 5 is equal to X. Something to know is that if you can then use that variable any way you could use the number 5. So I could say X plus 10, and it prints out 15. The important thing to know with that is that X hasn't actually changed. So if I make a new code snippet and just ask for X again, X is still 5. It's because I didn't reassign anything to the value of X. So even though the output here was different, X stays the same because we're not redefining it. Similarly, we could say like y equals hello. And then below that, in the same snippet, I'll call y, and you see we have hello. And you can actually do something I didn't cover before. You can actually technically do math, quote unquote, with strings. So I could say y plus, and I'll say and goodbye, if I can spell it. And if I run this, you'll see we get hello and goodbye. So adding them together actually added the two strings together. I think technically I could also do something like y times x, and I think this will just print hello 5 times. Yeah, altogether. So you can do you can do math on strings, as I guess is kind of the important thing to know. But you have to kind of, I think, play around with it to kind of understand its behavior. I don't think you could divide hello. That's actually a good thing to check. Yeah, it doesn't know that. You see here, it says this type. It says you can't, it's an unsupported operand, so you can't divide a string by an integer. So, but you can multiply. So that's just important to know. Okay, similarly, we're going to, you can make a variable a list. So I'll say flowers. I'm going to say flowers is equal to rose, daisy, buttercup, lily, and violet. So we have this list of flowers, and I can print it just so everyone can see. It's got there's all the flowers, and if we use type on flowers, that should say it's a list, which we know is true. But we'll get a little more into lists later. Any questions on variables?
No,
Okay.
everybody seems to be fine right now.
Okay, well, chug along. Oh, I guess one thing I should say actually before I move on to anything else is there are some rules for what variables can be named, which is kind of important to know. You can't. So when a variable can pretty much be named anything you want. The thing that you should be careful about is that you can't start it with a number or a symbol. It has to start with a character. So I can't say like one book equals 1984. We'll say. You'll see here it doesn't like that. It says, hey, this is an invalid token. This is actually basically it's saying that you can't do this whatever it thinks we're trying to do to the number 1. I think similarly, if we had another code and we had it be something like and then some equals true. I don't know. Oh, I shouldn't make it true. Yeah. So it doesn't like that. Just saying this is invalid syntax. So, but if I wanted to, I could easily do just and then equals true. And it doesn't mind that because it started with a character. You could have numbers too. So I could say like book 1 equals 1984. I'm going to put it in a string since it's an actual title. And it didn't mind that, but I just couldn't start with that. So now we're gonna talk about errors. You see, I've actually generated some errors, so we're gonna talk about them a little bit. Errors. Okay. Let's scroll down a little bit. So obviously, no one likes seeing an error, but I would encourage you to embrace errors because Python is, as far as programming languages go and scripting or mathematical languages, actually has really robust error handling, and it actually really makes it easy once you start to learn how to read it to figure out what's going wrong with your code. There are 2 kinds of errors. There's a syntax error, which you saw above. I'll scroll up so you can see. Syntax error, where it's basically just saying like something's weird with how you've typed this, and it can't evaluate properly. There's also what's called a traceback error, and this is when the program finds something that it can't do. For instance, like if you try to divide by 0. So if I say 10 divided by 0, and we look at that, we get it has a very specific 0 division error. So I guess that's not quite a good example. So that's that's a hyper specific error. But if we try to do like if we try to print something that's not actually a variable, I'll say print not a variable, which could be a variable, but it's not. We get a name error. I guess so. This might be actually a Colab thing, is that it's just.
I mean, it shows that it is a traceback as opposed to.
It's helpful in the sense of, when you see this kind of error, it usually gives you something fairly helpful. It tells you, where in your code the error is occurring, the type of error that it thinks it is. And actually, in the case of Colab, it actually lets you jump directly to Stack Overflow, which is, if some of you may know, is a popular site for like troubleshooting code. And then similarly for a syntax error, I'll show you. If you had something like a mismatched parentheses. So if I say print and I use a single parenthesis, I can do it on this single parenthesis. Let me actually manually delete the second one. I'll say this string has, not parentheses, sorry, quotes. And then I end it with a double quote. It's a syntax error, and it's saying end of line while scanning the string. And that's because, it was looking for the end to end that string with a single parenthesis. And since it never found it, it found the end of the line and said, uh-oh, something must be wrong here. So, the moral of the story is, errors can kind of look scary, but they're really helpful in terms of once you kind of parse them out. And it's kind of I would say the best thing to start when your code is wrong is just really try to read the error. In this case, the error is in line 2. It points to this little caret here. It actually shows you after where it has the issue. So in this case, it's at the end of the line. It's saying, hey, there's an issue here. The issue being that it doesn't have a single quote. And then it's saying it's a syntax error. And this is what kind of syntax error it thinks it is. Any questions about errors?
There doesn't seem to be.
Seems like we're okay.
Mm-hmm.
Okay, cool. So now we're going to get back to lists. Make a new little header here called lists. And that's some code. And we still have flowers loaded. So I'll just so you see it, I'll print it out here. I guess I should do print flowers. Print is actually, so one thing you'll notice is that you can just see a variable by just entering it, but print is important, and we'll see this more later, but when you're, like when you want the system to print something out, you usually should explicitly say print, and that means print it to the screen. If you just list it in a Python program, Python doesn't always know what to do with that, or it won't actually print it the value you want. We're going to do some simple programming loops, and I'll show you that it can just behave a little weirdly there. But so that's just why you might notice that it doesn't look any different at this point, but it does matter when you kind of when you need it to explicitly print to the screen. So we have these flowers: rose, daisy, buttercup, lily, and violet. And lists, how you can run functions similar to type. So we can write type flowers, which we showed. That tells us it's a list. There's other kind of functions you can run. For instance, if we wanted to know how many items are in the list flowers, we could use len, which is short for length. I can run flowers. You'll notice here that even though I actually had both type and len in the same cell, the same code cell, the only thing that printed was the last thing, which in this case was len, and the len was 5 because we have 5 items. And if you wanted to get fancy, you could even make a variable that is based on the operation of another variable. So if I say list length equals len flowers, oops, except we don't have flowers, so I have to change that typo. You'll see here, name error, flowers is not defined, so I correct that. And below that we'll print list length. And we'll run this whole thing, and you see 5. So we've assigned list length is equal to len flowers, and when we print it, we get 5. And another kind of important thing, and this can throw some people off. Again, if you've used R for lists or matrices, R starts at 1, like you count at the first cell is 1. In Python, it actually starts at the number 0. So if I say print flowers, and I'm going to do square brackets here to say I'm calling specific items within flowers, I'll say 0. And you'll see rose, which is the first item. That's for some people a little counterintuitive, but it's really just like you have to remember Python starts at 0. It considers that the 0th place is the one you start in. So you can see here, we called the 0th item, but you could do, you can call a subset of them. So I could say print flowers, and I could say the 1st to the 3rd, which means it'll actually start on position 1, which is the second item, confusingly, position 1, and it'll go up to position 3. It should not include position 3. So just we see, we'll print out, it should be daisies and buttercup and not lily. So it includes where you start, but it excludes where you end. Yeah, so we get daisy and buttercup. You can also do some stuff if you like wanted every item up to the 4th item. You know, you don't want the last one, but you want that. You could say print flowers colon 4. So this will give us the 0th, 1st, 2nd, and 3rd, but not the 4th.
Hey, Michael.
So this can be helpful for subsetting. Similarly, just so you can see, you know, if we wanted just the 3rd and beyond, we could print flowers 3rd on, and that just gives us the 4th and the 3rd and 4th positions, which is the 4th and 5th item of lily and violet. You could also, you can get a little fancy. I think like there are other things you can do to subset. I think technically you could like get every other one if you want like print flowers 2. I think this will skip every other one. Yeah. So this gives us the 1st, 3rd, and 5th items, or the 0th, 2nd, and 4th positioned items, because we skipped every other one. So just something to know, that you can kind of get fancy in how you limit it. If you wanted to, you know, create some sort of special list that was like a, you know, taking out other parts of a list. So if I wanted, you know, just Rose and Daisy, for instance, I could say, you know, flower subset is equal to flowers 0 plus flowers, I say Rose and Lily. So we'll just say the 1st and the last. That should work. Oh, well, it actually just put them together, so that's not great. I think maybe I'd have to do like, I'd actually have to create a list of it probably. There's probably a better way to do that, but just so you can see, like you could subset lists theoretically, doing things like that.
Hey, Michael, would you be able to speak to
say, like when we subset like this or pull out specific values, what we're doing is called slicing. You're slicing the list, and I mean, I think you can think of that intuitively of like you're cutting this list up into different bits based on, you know, where you start and end. Yeah. Any questions about lists?
Michael, can you hear me? Hello? Hello?
Oh, sorry.
Hello?
I couldn't hear. So sorry. I on the Macs, one of the frustrating things, they have this little touch bar at the top, which is, you know, it looks neat, but I have a really bad habit of just muting all sound accidentally. So
okay, I thought it was me. Okay, yeah. One quick question: Can you talk to a scope variable, a variable scope? You know how when you initialize a variable in one place, it stays set to that particular object that you set it to, but if you go further down and reinitialize it with something else, it does change. So
yeah,
you know.
yeah. So I guess that's a great question. So let's just do, I'll show you really quick. So, you know, we have, let's use X again. We'll say X equals 10, right? And we'll run that, and I'll say print X. So it says 10. And then if later, if we redefined X and we said X equals hello now. So we've run that. And now if we go back to the cell above it and run it, now it's changed to hello. So basically, the way you can think about it is that when you assign a variable, it goes into the, you know, into memory. It's saying, okay, I'll remember during this session while we're running this, that X is equal to this. And everything you call after it, before you redefine it, will always go to that value that's in memory. So one thing, I guess I think you can technically print out your variables. Let's see if we can. I think there's a way you can technically see your variables that are in memory. Oh, I think, yeah. So I think it's called dir. Oh boy. Oh no, this is, hold on. Oh, I see. No, sorry. Globals, I think, because we have globally, nope, okay. Not globally defined ones. What is it then? Oh, locals? Dang, okay. Oh, that was actually locals you can see. Okay, this is a little messy because there's a ton of stuff in here, but you can see these are actually all the things I've defined. Although it's not saying what they're equal to, which is annoying. Oh, down here.
Yeah, it's down there.
Yeah, down there you can see X and Y are equal to hello. So that's a little messy, but you can, wow, it's a lot of output.
I'm sure there's a cleaner way to do it, but that's kind of the gist of it. You'll have some type of function that you'll be able to run that'll show you, everything that you initialize, variables, things of that nature. So what Michael was showing you is pretty much it. Just there's some other ways to do it cleaner to the eye.
Yeah, I guess personally, again, as a person who usually uses R, one thing I like when you use like RStudio is that RStudio actually tells you all of your variables that you've defined in a little section, where Python doesn't, but it works in a similar way, where it's basically, whatever was the last thing you set a variable to is what it'll carry forward in your analysis. So, if you're working with a notebook like this, you really don't want to define something and then go back up to another cell that's already using that. That would be kind of bad practice. But if you just need it to carry through to the things after it, then that's fine. Just to let it, you don't have to reinitialize it every time. Because as long as your session is open or your notebook is open, it'll just keep that in memory. I think technically, in the Google Colab, you can actually see up here what our memory used is with that RAM used. So that's where those variables are living, I guess, is in that RAM. Cool. Okay. So now we're going to talk about loops. I'm actually going to make a new text. And oops. And a loop is if you wanted to have code that will process through something like a list and then do something in response to it. That's the essence of a loop. So for instance, I'm going to teach you what's called a for loop. And that's literally when you say for. So in this case, we'll say for flower in flowers. And put a colon. And I hit enter. You'll notice that it automatically indents. Something to know about Python is that Python syntax actually depends on spacing. So it needs to be indented to run properly. And I can show you this in a sec. But so we'll say for flower in flowers, print, look at this. And I'll say flowers. So what I'm doing here, flower, you'll notice we've never actually defined flower before. Flower is really only being defined in this case. It could really be anything. But what I'm asking you to do is that for every flower within flowers, the list, it's going to print the sentence, look at this flower. So we say, look at this rose, look at this daisy, look at this buttercup, look at this lily, look at this violet. So just so, again, you can see, if I just say like print flower. Oh, interesting. So flower is defined now because it was defined when we ran that list. And the last thing was a violet. So that's why that works. But we never defined it before. So that's actually interesting that carries through, because let me see if I say for X in flowers, print that. Let's just see what that does. Yeah, okay. So now that's something I guess you have to be careful about, is that now X is now apparently always violet. So if you use some sort of placeholder or temporary variable, I guess it becomes the global variable, which I thought it wasn't supposed to do. But yeah, so yeah, but again, flower could be anything. It's just any placeholder variable in the list, which again just iterates over the list. We loop over the list. So what it does is, it looks at the first position or the 0th position, and it says, okay, so we're in flowers. For flower, the value is rose. So what does it want me to do with this value rose? It wants me to print, look at this rose. Okay, I do that. What's the next one? And it goes to the next position and does the same thing over again. I think technically, you can do this. There's some things to know about it. So like I could say for letter in hello, colon print letter. That should actually print each letter out individually. So that's something to know. If you run a loop over a string rather than a list, it'll actually just go through every character in the string. I don't think you could run it over a number. But yeah, basically, I mean, the thing to know is that, the essence of a for loop, because there are different kinds of loops, the essence of a for loop is to, for a variable in a list or an object, is to do something for each of those objects. Any questions on that?
There doesn't seem to be. And one thing that you mentioned about number, I guess if that number is converted into a character string, then you can go through it. But if it's an actual number, you can't, because you can't index a number.
Right. So if I said for letter in let's stick with 1984, but it's just the number, right? Print letter. I don't think that'll do anything. Yeah, it doesn't like that. But if I did make it into a string, then it'll do it. Yeah, just to show it. Caesar was talking about. Similarly, like, with math, because that's probably more relevant, let's make another list called prime numbers, and we'll set that equal to 2, 3, 5, 7, and 11. And we can just print it to make sure. 2, 3, 5, 7, 11. Now, if I wanted to see, like, what is the square of each of these numbers, I could say for square in prime numbers, colon, print the square of, you can see I'm leaving this little space just so it doesn't get squashed together. But I'll say square of square. I guess I should maybe say for number in prime numbers, the square of number is, and we'll say number 2. So that's to the second power. Or, yeah, wait, that's how you do it in Python, right? Let's see. Oh, what have I done? Oh, I forgot to add a plus here because I'm adding these things together. So the square of the number plus is plus number times 2. Actually, maybe I should put that in a parentheses just to make sure it knows to do that. Or didn't I like here? Must be str, not int.
Yeah, because in order to add a string, you have to add a string to another string. You can't add an integer to a string.
Oh, yeah. Right.
So I guess you could convert it if you really wanted to.
Yeah, I think, yeah, you could convert it. I think it's something called like an F string.
I guess you can use a string function and kind of.
Yeah. So I could do str number. Let's see if this will do it. Actually, that should do it. Yeah. Okay. So thanks for that, Caesar. So in this case, what I did for everyone can see is str with the parentheses is converts it converts an object or a variable to a string value. So in this case, I converted number, which the first number is 2. So it converted that to a string. And then within the next one is 2, 2 squared. And so then we've put that all together. So you get the square of 2 is 4, square of 3 is 9, 5 is 25, 7, 49, et cetera, et cetera. So you can see how like loops can be kind of powerful in terms of being able to do complex operations, complex operations over a large list. Because you could imagine if we had a list of 10,000 prime numbers, this would be an easy way to get all of those values. Any other questions before we move on?
Looks like everybody's good right now.
Cool. Good. Okay, so we're going to talk about conditionals. This is kind of how you can take loops to sort of the next level. Is if we do operations over certain items based on if a condition is met. So, for instance, we'll make a little application. But first we'll say, the weather. So the weather today is a little dreary. I don't think it's raining, but I'm going to say, let's say rainy. Weather equals rainy. Okay. I'll print weather just to make sure. Yeah, so the weather is rainy. Now we're going to make a little loop, or a little, I guess we should say a little conditional. So we'll say if weather, and this is what I did before, if you remember the 2 equal signs to evaluate, I'll say if it equals sunny, print, I had the colon there, print wear your sunglasses. And you notice that this looks a little bit like that for loop, but it's a little different because it's not actually a loop. It's just evaluating something. We can also then say else. And we'll say else, print. So if this is just evaluating, it's not sunny, we'll say it's not sunny, so be careful. And if we run this, which I just did, you'll say it's not sunny, so be careful. So you can see here that it looked at weather and it said, it checked to see if weather is equal to sunny. And if that was true, it would have printed wear your sunglasses. Otherwise, because it's not true, in this case else, which catches everything else, it's just saying it's not sunny, so be careful. Now we can expand on this a little bit. So if we wanted an alternative condition, we can use what's called Alif, which is basically an alternative if statement. So I could say if the weather is equal to rainy, print bring your umbrella. Now if we run this, you can see the output changed to bring your umbrella. And this might be a good place, moment just to to show why we use print. Because if I do this and I didn't use print in this case, and you can see that nothing came up when you'd expect it to be printing bring your umbrella. But since we actually wanted it to explicitly print to the screen, we have to actually say print. So that's just to illustrate what I was talking about earlier. And you could, theoretically, again, you can have as many elifs as you want, right? So I could say elif weather equals snowy. Print wear your snow boots. And you can have as many of those as you want, but it's only going to evaluate on the one that's true. Yeah. Any questions on if statements and conditionals before we just kind of take it to the next level?
There doesn't seem to be any.
Great. Thanks, Caesar. So just something to kind of build on with the conditionals that is, I think, kind of naturally goes with it. We'll make it its own section just because I think that's just for clarity. We'll call it input. And this is actually because you can ask or have Python ask for inputs. So I could say, greeting is a variable, and I'll say that's going to be equal to input. Not input, input. There we go. And if I actually run this cell, you'll see something happens. I actually get this little prompt, and you can see it's still running because it's actually just waiting for me to type something. So here I could just type hello. And then it gets it. And now, if we say print greeting, it's still hello, because that was I guess it might seem silly, like why would I do that in my own space here? But you could imagine if you were writing some sort of application, you'll at times need to get input from whoever's using that application, and this is how you would be able to get values like that. So you could imagine, our little why don't I just copy our little statement from above? And what if we said, if weather, let's just say, let's try this all again and just say weather equals input. So now I could say, what is the weather? And I could say, you know what, it's cloudy. And it looks at it says, I don't know what to do with this because you didn't define this. So I'll just say it's not sunny, so be careful. But if I ran this again, asked for a new thing, I could say it's sunny. And it says, okay, it's sunny, so wear your sunglasses. So that can be nice, in terms of, again, getting dynamic input from either yourself or a user. Maybe not the thing you'd use most commonly if you're trying to use Python for like data analysis, but it's a good thing to know. And I think technically, just one more thing is that this is kind of actually for my own benefit. So we typed in hello before, but let's just make sure what greeting is. And if we look at it, it's a string. But perhaps if we said greeting equals 5, it should then tell us an int. So it's pretty smart. But if you wanted a sentence, hello there. Yeah, it's still a string. So, oh, sorry, I should do that with the input because that's what I was testing. So if I said hello there, it says, okay, it's a string versus this. If I said 5, oh, interesting. So input is always a string. That's actually good to know. That's what I wanted to test out, actually. Yeah, so no matter what with input, it treats it as a string. So just something to know if you wanted to put in math. I guess technically, you could, if you knew it was going to be a number, you could do something like int input, and then I could say 10, and then okay, now it knows it's an int. But yeah, so just to know that input will default to a string. We could also just do something, again, kind of combining other functions we've learned. So, you could, if you wanted to, like, I mean, this would be a little arbitrary, but just see how long someone's input is. You could have, let's make a new variable called length of input. And that's going to be equal to the length of input. Here is my input. Oh, I have to then print length of input. Oops. This is my input again, I'll say this time. This is 22 because it's 22 characters long. So moving on from input, we're actually going to take a backtrack slightly to lists again. And we're going to call this list operations. And this is important because, we covered a little bit like slicing, but there's actually a lot more things you can do with a list. So we still have our flowers, right? So I'll just print flowers, make sure that's also there. Rose, daisy, buttercup, lily, everything's there, so that's great. But you know what? Like, what if I look at that and say, this order doesn't make sense to me. I really wish this was alphabetical. You could actually just do flowers dot sort. And you might notice this is a little weird because we've seen sort or functions before. And this looks like a function because it ends with a parentheses. But it's weird to have it trailing after a variable that we set. And this is because object types have associated functions within that are associated with them. So we can call specific functions by using the period with the function name. So in this case, this should give us, I have to print it. Of course I have to print it. I made such a big deal about it and then I forgot to do it. Oh, well, Oh, you know what it is? Okay. So I did flowers at sort, and now I should have just printed flowers. So now you'll see we actually changed flowers with that flowers.sort. So now no matter what, flowers is in order. So I guess that's something to be careful about. Yeah. And I guess I should say, this kind of function, like dot sort, that's called a method. Methods are very similar, obviously, but there are ways of doing things that are attached to these objects. I mentioned before, Python is what's called an object-oriented language. There's a lot that goes into that, but I mean, the way to think about it is that similar to variables, you're always defining things. An object is like the basis of a lot of the programming language because everything is an object where it is like as defined as a variable or a type of function or there are things that are attached to it, but it kind of exists as a sort of conceptual thing. So flowers, is a list, which is an object as far as Python is concerned. I think that's probably a little off and a little reductionist, but just so you can kind of get that idea. And just some other little things to touch is, sort is the method, and this little period is actually technically called an operator in Python, and it's just part of object-oriented programming. Okay. So, sorry, that was kind of like a lot of word vomit. Is there any questions specifically about methods or what I was just doing there?
There doesn't seem to be anything coming through, so I think we're good right now.
Cool. So kind of doing other methods, just so you can see, what if we wanted to add another flower, say, right? So I could append our list. So I could say flowers.append, and let's add what's another good flower? Violets, daisies. Let's say lilacs, kind of like lilies, and then print flowers. You can see lilacs pops in at the end. You'll notice that it just goes to the end. It didn't, even though we'd sorted, it doesn't sort it in that case. But if we wanted to, we could always do flowers.sort again, in which case lilacs. Oh, I added it again. Whoops. Probably can do can I do a subtract? Oops. There's probably some sort of like unappend.
You can try, I think, remove. I don't know if that one will work for you. You can try
it's
remove
one of those
it.
things, yeah.
Mm-hmm. But then I think, let's see. There you go.
Yeah, so it removed one of the lilacs. But if I run it again, it'll remove both.
Move the other one. Yeah.
Now if I run it, say it doesn't, there's none there. So oh, so now I'll comment this out. Yeah, remove is the opposite of append. But in this case, again, you can see we added lilacs, we sorted it so it went alphabetically, and we printed it out. Okay. Sorry, just lining up. I have 2 notes up right now, so I'm trying to make sure I'm covering both things. Okay, what is... Oh, so, sorry, this was what was confusing. So we had remove, but one thing, and just to show you another type of list operation, if we have flowers, let's not append, and let's call this mistake. So we don't actually want this here. Shoot, except I just so we can all see. Sorry, I had to make it. I put it in parentheses, so because I didn't want to add it twice. Basically, you'll see here. So I added mistakes at the end. They go, oh no, I didn't want that there. A quick way you could get rid of it. I'm not entirely sure how useful this is, but maybe it's useful. But you could there's a method called pop. So I could say flowers.pop, and then print flowers. And you can see it, quote unquote, pops off the last item. So you can see there we removed mistake. And that actually kind of reminds me, when I was showing you how to like slice the list, one thing I didn't show, let's add mistake back. And so you can see we've added mistake. If I just wanted to get rid of, well, maybe not get rid of it, but like if you wanted to see what's at the end of your list, I could do print flowers and square brackets -1 to see just the last thing that's there. And you can see here, the last thing's a mistake. So in which case, I could just do flowers.pop and get rid of it. Actually, let me just make sure I print flowers. Yeah, so it did get rid of mistake, even though it printed it there. Okay. So, it looks like we have a new question in the Q&A. What is the easiest and fastest way to find all these methods that you're looking for? Oh, that's a good thing that we should go over. Obviously, you can always Google or search whatever you want, but there's actually built-in when you use Python. There's actually built-in help. So if I wanted to know something more, I guess the methods could be a little hard. But if I said list, I think this would actually show us. So I say $list, and I ask for the help, and in here it says, okay, list is actually a function. I think there's more help you can get though.
So I'm wondering in Colab if when you were typing flowers, then you put a you can get there you go.
Yeah,
and,
so right. So you can ask for help. The question mark brings up a little help, but I can say help flowers, and then it says, okay, you want help on a list object. And then it can give us a little bit of insights here. So it says, this is how you use list, the function. This was actually in that little pop-up we had. And it gives, again, a lot of information here. So these are the methods that are associated with it. So we have append, which we went over, clear, which I think, yeah, that removes all the items, copy. Not sure what a shallow copy is explicitly. Count, which will count certain values. So, if we had, why don't we try that? So we've just learned count, which counts a value. So what if I said, flowers dot count, and we'll say rows. How many roses are in our list? Should only be one, but you can see that might be useful if you had a, like if you had a survey to say and you wanted to see how many people responded yes to something. And there's other things here like reverse, which is kind of like sort, but it gives you in reverse order. Yeah, so help is a good way to go. For quick little things, I also like the question mark. I wonder if I can just do question mark flowers. It's probably the same thing. Yeah, so question mark flowers brings up this like mini help. I'm not exactly sure why they're different, but I think you have kind of, when you use help, it gives you the full-blown help screen versus sort of like a condensed version in this little pop-up. But you can see it still recognizes the same thing. So it's like, okay, this is list. Perhaps the question mark gives you just sort of like quick sort of summary information about whatever you're asking about. Okay. So, we've pretty much come to the end of what's covered in this. I mean, there's a few things. There's a few things we could potentially look at. Perhaps a while loop would be actually valuable to go over. I'll do, just because we have a little bit of time left, I'm just going to see if I can do quickly while loops, because while loops are a little different than for loops, and I think they can be helpful. So let's set x equal to 5, and where we'll say while x is greater than 0, print x, and then x equals x minus 1. And let's just see what this does, if I did it right. No? Oh, but while, okay, sorry. I meant greater than 0, because it wasn't running, because 5 is never below or less than 0. So in this case, what I've said is while it's above 0, do this whatever's inside. And so in this case, I just had it print, and then I had it reduce the value of x. So in each case, it gave us down to 1, but as soon as x is equal to 0, which I think if we add another thing here, just say print x, you can see x is now 0, so now this will no longer function. Gotta be a little careful, because obviously, if you screw it up, like if I put +1 here, we'd actually have what's called like an infinite while loop, because it would run forever, because it would never stop. If we started 5 and said, while x is greater than 0, do this, and then kept adding numbers to it, or even if we didn't have this here, actually, in this case, I think what it would do is only run one time. I don't want to run it though, because I'm scared I'm going to crash it. But let's find out. Yeah, so it'll run 5 infinite number of times, which is obviously not good. Oh, and it was smart enough to actually stop it, which is good. But that's why you want to be a little careful with while loops, because it's if you're not careful, it's a good way to crash your program, but it's pretty easy to get back to it. But if you had a program that was something possible, like if you had someone if you get used input and someone could break it that way. You just have to be cautious using that kind of loop. Okay, great. So, I mean, I think we're set to go to 5:30, but those are kind of the major topics I wanted to cover. Oh, sorry, there's one more thing that is kind of handy. And I'll say string operations. And just because this is kind of handy, if you're working with text data, you'll know that if hello, if I ask if hello is equal to hello and I capitalize something, it says false. These are not equal. So sometimes you want to do operations on strings to help make things uniform. So I could say like string 1 is equal to hello, and string 2 is equal to hello, right? So we have both of those. I could say upper string 1, and I can see if that is equal to upper string 2, and upper is not oh, sorry, because upper is a method, not a thing. So I'd have to say, okay, string 1 dot upper, because it's a method, not its own free floating function. So if we do this, it's true. And that's because upper, as it may sound, capitalizes, whereas there's also lower, so string 2, makes everything lowercase. So just kind of a good thing to know if you're using a lot of string data, because you can imagine anyone who may have dabbled in natural language processing, or if you're doing text analysis, you have to be really careful with words that as a human we would evaluate them as the equivalent, but to a computer they're not. So just something to keep in mind. Okay. Any other questions?
There's one question. I think it's more along the lines of, where do I go from here? They're asking, how do I add on to what we learned today? So, I think you mentioned it before, with Google, but I'll let you take this one as well.
Totally. There's a lot of really great resources out there to continue learning Python. I think it depends on where you want to go in terms of if you're hoping to use Python for more of a programming language, or if you're hoping to use it more of like a data language. I think one of the hard things too is that there are both free and paid things. I think Data Camp is a tool I've used that has a free intro to Python that's a little more in depth than what we've done here. But I think they have a lot more Python courses, but I don't know how many, if any other ones are free. I think it's datacamp.com. Just check that. But there's a lot of things like that. There's a lot of great books that are free. I think the O'Reilly series of books. O'Reilly series of books. They have a ton of books called Learning Python. But I mean, there's a lot of places you could look. Is it Datacamp? Oh yeah, Datacamp just changed all of their stuff, so this is confusing to me. But Datacamp has free, like Intro to Python courses, or a free one, and then the O'Reilly books. And I can see if I can. Which one did I use? So here's a book. If you're interested in doing like Python for data analysis, here's a, this book isn't free. I think you can usually get the O'Reilly books free somewhere though. That would, I guess, be my starting suggestion. But yeah, it is. Oh, I see. George is also. George has posted something. Oh, but I think I have to send it. Make sure it's to the attendees. There is a Python user group, and I'm going to share this through the Research Computing Foundations. So if you're interested about learning more in Python, I think they'd be a really great resource. They have events once a month, and they've done really cool things. Like they brought in, I know one time they brought someone from Google. I think they brought one of the people who works on Anaconda, which some of you may have heard, Anaconda is it's a really popular way that Python is kind of bundled together especially for people using Python for like data analysis. It helps you create sort of like you can use it to create virtual environments that let you install packages and keep things kind of contained and organized. And it also comes with some built-in tools and programs to help make using Python more easy and efficient, such as Jupyter, which a Jupyter is that's Jupyter, is the basis of these style of notebooks like we worked in today. Again, we used the Google Colab, which is very similar, but you'll notice up here, this is it's Intro to Python IPYNB. That's IPython Notebook, and that's because this is a open source format for using Python, interactively like this. So, but yeah, the Python user group is great. I really am a big fan of the O'Reilly books, and I've had also, when I was first learning Python, I found DataCamp to be helpful. But there's a lot of resources around campus. I think the libraries, I know they do R workshops, but I think they also do Columbia. I think they do Python workshops too. Yeah, I would check out the libraries. So they do a lot of.
And there's another question in the Q&A, and you probably touched on some of this before, but the user is asking, what other applications can you use Python for, and what are the advantages of Python over other languages?
Yeah, that's a great question. Python is, I think, technically still at this point considered one of, if not the most popular coding language in the world. The reason people gravitate towards Python, there's a lot of support for it, but like as a language compared to something like Java, as a person who's tried to learn Java, I will say I don't think it's personally very friendly to people learning code. Whereas Python, because of the way you write it, and we didn't get too far into this, but so just like in this while loop, right? I think that's kind of a good illustration. The thing that's farthest left is like it evaluates that on its own, but when you indent, it evaluates that as part of a whole, right? So it looks at these two indented lines as part of while, and that's baked into how Python evaluates code with these the sort of natural indentation. And the results of that style makes Python really human readable. I'm a little biased again as an R person, but like R is, I find R to be even easier to parse out because I find methods can be a little confusing at times. But the real benefit is that Python, unlike R, is a full-blown coding language. So you can build applications in it if you want. It's got a huge open source community that are constantly adding and updating and building things on it. The notebook interface that we've used here, again, is kind of one of the modern paradigms for being able to write and share code. And there's also a lot of the libraries borrow or are built on other languages as well. So a lot of the things people may have heard of, like in AI or machine learning, there's things like TensorFlow and PyTorch, which are actually built on a different language. I believe TensorFlow is built on C++ or something, because it's a really fast language, but again, a hard to read language. So that what they do is they'll take advantage of these languages that are really powerful and fast, and then make it very human readable and easy to interact with. And I think that's at the heart of Python, is like the real benefit compared to other languages, is that it's just so much easier to pick up and learn, and just to be able to start doing really powerful things very quickly. And I think that's really what has drawn people to Python. I think in that Q&A, I think there was questions too, but just like what other things besides data analysis and math. Yeah, I mean, again, like Python can technically do anything. It's open source, so unless you're writing your own packages, you're limited to technically what other people have written. But like many times, like you'll find that Python is at least part of a lot of things you interact with. The Pythonian web applications, or something dealing with databases. A lot of times Python is used in conjunction with programs or applications that have to use databases. It's again, I'm not a Python programmer, so maybe I'm not the best person to answer this, but in a nutshell, you can technically do anything with Python. It's probably not the best tool if you wanted to be a web developer, say. You might be better off learning or focusing on other languages, or like JavaScript. I know is still kind of at the forefront of web development, but knowing Python wouldn't hurt you. I think it's a very friendly language to start with too. Yeah. Any other questions? Okay. So looks like I think we have to wrap up. So we'll call it here, but we will share this with everyone else, or with everyone who attended later. So thanks everyone.